Okay, the hardest part with these videos is not having students here to correct your work. So just that example there, some of you are wondering where did the negative 12 come from? And it's kind of a magical thing. It actually should have been 9. So if you're thinking this should be negative 9, you're absolutely correct. So hopefully that didn't cause too much confusion. Didn't really change your answer. My biggest question when people ask, why are we doing the matrices? Why can't we just use substitution elimination? If you look at this, we essentially solve 3 equations, 3 unknowns in 1, 2, 3 steps technically. If you were to do this with elimination, and always feel free to do this on the test, and this is just a, I'm not actually going to do it because it's way too much work, but some people need to understand the why part of it. With elimination, if I would label those equations over to the left here, equation 1, 2, and 3, we would have to use, step 1 would be elimination of equation 1 and 2. And that would create a new equation we'll call, I can't call it 3, so we'll call it 4. Then you'd have to do the elimination of equation 1 and 3, which would create a new equation number 5. Then you'd have to do the elimination of 4 and 5, and that would get you down to a final value. And then you'd have to sub into 4 and 5 to find all values. So you'd have to do, you're performing elimination minimum 3 times in order to solve that. And like I said, if that's the method you want to go with, fine. But for anyone that's continuing on to university, you are going to have to use matrices at some point. So best now to try practicing. So I'm going to do a summary at the end of the examples here. I want to get through a couple more examples and then draw the summary together for you, which is going backwards in the slides. So again, hopefully some people are starting to see what the pattern is here. So the first thing I do is I scan and I see, hey, row 2 has really almost a 1 in front of it. So I'm going to do this. I'm going to interchange row 1 with row 2, and I'm going to multiply row 2 by negative 1 before I even go into the matrix, because that automatically will make that a 1. So it changes all the signs, right? So 1, negative 3, negative 2, positive 3. My next row then would be 2, negative 2, 1, and 0, 2, 6, 12, and 10. All right, so we already have the 1. So you always work down in columns. So once you have that 1, you now work down that column and make it look 1, 0, 0, 0 until you're out of numbers to do. So need to make that a 0. I'm going to take row 2 and I'll subtract 2 times row 1. So again, that first row, once you have a 1 in the first spot, it never ever changes. So I'm going to end up with a 0. Now let's see if I can do this. Negative 2 plus 6 would be a 4, and a 1 plus 4 is a 5, and a 0 minus a 6 is a negative 6. If I make a mistake through here, okay, it's not intentional, so you can make the change accordingly. I'll figure it out eventually because it's going to get really ugly for me. So anyway, row 3, going to be the same instruction since it's the same number. So I get a 0. Now I have 6, 6 plus 6, just double checking that, that's awesome. And 12 plus 4 is a 16. And a 10, take away 6, is a 4. All right, so this is working out very, very nice because I'm just kind of cheating ahead on myself. So, okay, I have my 1s there and my 1, 0, 0. Your next job then is to get a 1 and a 0. So really all I have to do is get a 1 here because I already have a 0 there. So I'm going to take row 2 and multiply by a quarter. We try to avoid division. It's not kosher to use division with the matrices, so we always try to do it as a multiplication. So again, that first row does not change. The second row gets multiplied by a quarter. And the third row is all set for us. Now, we're on to the last spot or last location. I need to make that a 1. So you just do row 3 multiplied by 16th. And actually, when you get more comfortable with this, I'll point it out now, you can actually do that step, oops, do this up here, okay, and do it all in one step. So I have to write out one more matrix here, but feel free, because when you get better at this or smoother at this, you can do this actually in probably two matrices, and that cleans everything up for you. The 6/4, I'll reduce it to 3/2, and 4/16 is just 1/4. So there we go, all done. I'll do the rough work off to the side here just to give me a bit of space. So what does that tell me? Take the bottom row, and you always start on the bottom row. So that one right there. What does it tell me? I have no x, I have no y, but I have one z, and it's equal to 1/4. So there is one of my values. I move up a row. So now, I'm having fun with my colored pens. There we go. I have no x, but I have a y plus 5/4 of a z, and it's equal to negative 3/2. So do my substitution, because I know what z is. Z is 1/4. Now I'm cheating here a little bit, because I know that on my next line, 5/4 and 1/4 is really 5/16. So I need a denominator of 16 over here. So that means I had to multiply the bottom by 8. So the top gets multiplied by 8. So now I take 5 away, and I get 29/16. So now I have a y value. Moving up one more, I have an x minus 3y minus 2z equals 3. So x minus 3 times negative 29/16 minus 2 over 1/4 equals 3. So I'm going through this. I see that I'll have x plus, now 3 times 30 is 90. So you go less 3, so that's 87/16. And I want everything over 16. So 2 times 1/4 is 1/2. So that means I want it over 16. So I multiply top and bottom by 8. So that'd be 8/16. And I want this over 16. So 3 times 16, 48. Okay, so there we go. It's just cleaning it up. So x equals, so 87 take away 8, that would give me 79. And I'm going to do 48 take away 79. And that is going to be, well, you know it's a Monday when? Negative 31. So negative 31/16. Okay. So that tells me that the solution to these three equations, three unknowns, is going to be negative 31/16, negative 29/16, and 1/4. So you found the point of intersection. So this is, therefore, an independent system with one solution. All right. So again, how fast is it? Well, rather than doing all those eliminations, we could have done it in 3 matrices. We did it in 4, and then it's just the algebra substitution that's left. And the only reason it was a little bit trickier is because there's some fractions. And believe me, I try with the homework to not have too many since you're not using a calculator. So on to what I think is the final example here. Just double checking, yep. So final example, and then a quick summary. So when I'm looking at this one, really no ones to start with here for coefficients. So right away I'm going to take row 1 and multiply by 1/2. Save me one step. So I end up with a 1, negative 1/2, a 2, oops, that would be a 1, multiplying everything by 1/2. Now, nothing's a multiple of 2, so I'm not going to get too fancy off the start here on you. So we'll just add those numbers in. So again, your first goal with the matrix, We want to get this looking like a 1, 0, 0 going down. So I need that to be a 0. So I'm going to take row 2, take away 3, row 1. So again, that first row, it's locked in stone now. It's not going to change. Next, end up with a 0 and 2 plus 3 halves. Write that out. 2 plus 3 halves, so that's 7 halves. And the next one would be negative 1, take away a 3, so negative 4. And negative 2 plus 9 halves. So that should be, what do we got there? That'd be a negative 4, so 5 halves. All right. Got me under the gun here. Now I'm all nervous. I don't have students firing out the answers for me here. I got to think for myself. Minus 5, row 1. So we get a 0. So 8 plus 5 halves. So that would be 16 plus 5, 21 halves. And then negative 7 minus 5, negative 12. And 0 plus 15 halves. There we go. So we have our 1, 0, 0. Our next goal is to get 1, 0 in that column. Whoops, I've lost all my work. There it is. All right, so again, that first row stays the same or untouched. That's interesting. So 1, negative 3 halves. So now I'm going to take that 7 halves, and fractions are never a problem at this point because you just multiply by the reciprocal. So I'll have a 0, a 1. I'm going to have negative 8 sevenths and 5 sevenths because the 2's would cancel out. 21 over 2, so row 3 multiply, oops, not trying to make it that way. So here again, I ask myself, with this row elimination, the 21 over 2, I want to make it a 0. So when I look at this, okay, is this row something that I can use? Well, 7 halves is just 3 times, if I multiply it by 3, I get 21 halves. So actually I can use that one, and fairly easy. So row 3 minus 3 times row 2, we'll clean it out. Okay. Never, ever, ever, once you get that first row, and I should stress this earlier, okay, we never use row 1 again if you notice. You're working your way down. Okay. So, there we go. So we got a 0. 21 halves minus 21 halves is 0. Negative 12 and negative 3 times negative 4 is positive. So that would be a 0. And 15 halves minus 15 halves is 0. So we get all zeros across the bottom here. And I just want to check here. I'm not sure if I have enough time to finish this up. We can try it very, very quick. So what's happened now? I have 0x plus 0y plus 0z equals 0. So what value of z makes this true? And the answer is all values of z. So basically, you can pick any value you want for z. So if 0z equals 0, then let z equal t, where t is any number in the world. Okay? So t is any number in the world. You can pick whatever you want. So then working our way back, we get y minus 8 sevenths t equals 5 sevenths. So y would equal 5 sevenths plus 8 sevenths t. And then continuing along, again, just making sure I'm cutting too close for time here. So I'll finish this up and then I can do my summary in a short video to end this. So see you in a minute.